Hi. Whoa. Maybe I was a little enthusiastic there. Hi. Hi. Is this better? This is better. How are you? Good. Wow, that was actually pretty awesome for like one session removed before the end of the conference, you know. We're in the home stretch. We get a little tired, but that's good. That's good. See lots of bright eyes out there. This is awesome. Well, you've come to a great talk, at least I think so. My name is Spencer Schneidenbach, and I'm here to talk to you today about expression trees in C#. Now, C# is just the language example, but you could do this just about, you could do this in VB.NET as well. Most of this stuff applies. Any VB.NET people out there that want to admit it? Yeah, there's a few of you. I'm still in once occasionally. So, first things first, got to get this out of the way. You can find me on Twitter at Schneidenbach. It's just my last name, so you get that piece, baby. You don't have to write it down, right? You can get the slides plus more at schneids.net. I will also be tweeting out a link to the slides and the link to a few other resources and a few other things along the way. So I'm going to be using Twitter throughout the presentation to tweet out some example things that I think are useful, some little demos that you could use and follow along with as I'm giving them. All right, so without further ado, let's start by talking about expression trees. Now, how many people in this room have used something like this, a LINQ expression, either the query syntax or the Lambda syntax, to query a database? How many people? Query a database. Entity Framework, LINQ to SQL. All right, all that good stuff. All right, very good. How many people have been asked to render a field like this using ASP.NET? They're using ASP.NET MVC, and they're like at html.editor4, and then it just produces a bunch of magic stuff, and like validator4 and all that. All right, very good. How many of you have been asked to ever use some kind of code where you had to select one or more members of a class or a property of some kind of like this, right? All right, well, if you have done anything like write a Lambda expression, then you've used expression trees, even if you had no idea. And so we're going to talk about that. We're going to talk about some examples in the real world, in libraries that you use every day where you may not even be aware of them. And a real-world example that I've used, as well as a few that you can use that kind of chew on to see how expression trees could help you in your development life. So let's start by talking about what expression trees are. And before we can talk about expression trees, I think it's valuable, I think it's useful to talk about what a Lambda expressions. So this is a Lambda expression. This is one that's declared in line inside of a variable. So we have func of string, which just says, defines a function signature that has it's a function that takes in a string and returns a string. And our toUpper function, all it's going to do is take in that string and call its toUpper function on that. And so what happens when I call that function right in line, because you can do that if you've never done this before, it's cool. You can do that. So what would I reasonably expect to get as a result of this function? I'd probably expect to get my name capitalized, Spencer, go from lowercase to uppercase. All right? Pretty straightforward. Let's declare the exact same thing, exactly the same way, except we're going to add an expression. So this is an expression of func of string. And we're going to do that. It looks the same, so that top line works. So we're going to try on the bottom line. What do you think I'm going to get? I'm going to get a compile time error. Well, what the heck is up with that? I mean, they look almost exactly the same. It looks like a Lambda function. Both of those things are compilable code. So what's going on? So the key difference between a Lambda and an expression is that a Lambda does the thing. An expression tree, a Lambda expression specifically, describes the Lambda that does the thing. So this is really important, though, because this is actually a really important feature of expressions as they relate to C# and VB.NET. These things, it's really cool. They share a property called homoiconicity, and I think I'm saying that right. I don't know. I've never looked it up. And homoiconicity basically says that the syntax that you can use to write a function, you can use that exact same syntax to declare expressions that describe that function. So that's a really powerful concept because it looks natural. It looks and feels natural. When we write Entity Framework queries or we're selecting members using HTML, editor4, anything like that, it feels like a natural part of the language because it is. It feels like you're just naturally just writing a Lambda function, even if they are doing some cool magic. And we're going to talk about what that magic is. We're going to talk about what we can do with expressions. So we can read them, create them, and use them. So let's take our toUpper example here. We're going to go ahead and decompose this thing. We're going to break him down into his component parts. So as you know, a lambda is made up of a set of parameters, 0 or more, and a body, which tells you what the thing does, right? So in this case, our string function takes in a string, returns a string, okay? And a parameter and an expression can be broken down and read by its component pieces. For example, I can take the representation of this thing during runtime, and I can start interrogating that expression and say, what are you? What is it that you do? And we're going to get some code representations of that expression. So on the left side, we've got our parameters. So what we're going to get is what's called a parameter expression. And a parameter expression simply defines a parameter to an expression, right? And then on the other side, on the right side, we can break this down into two different things. So we have a method call expression, which calls string.toUpper, is basically representing that call to string toUpper. And then we have the parameter expression that says this was the target. This was the thing that I called toUpper on. So you can break this down. You can inspect that expression at runtime and ask it things about what it does, which is really cool, and we'll show you why in a bit. You can also create them. So this is an example of creating just the same as we did before, and we do this a lot when we use Entity Framework or we use AutoMapper libraries like that. So this is good, this is useful, but it's mostly useful for libraries that consume the expressions. Well, what if I told you you could create them at runtime? And you can using what's called the expression API, which is really neat. You can use the expression API to build expressions at runtime very easily. And let me show you. So again, functions having parameters in a body. Here's an example of one that also takes in it takes in an object that has a last name property, hello, comma, with the last name. So again, talking about that parameter expression, this is how you declare. Instead of, if we declared something like this inline with that x, we get a expression that is an expression that contains parameters and contains a body. But we can also build them at runtime using the expression API, and we do that by using these static methods on the expression class. So we call expression.parameter, and what we do is we have one of two signatures. We have a signature. So one thing about a parameter, it always has a type, right? It could be object, it could be string, but it always has a type. So we can declare a parameter inline that has a type of string, right? And then we could also give it a name, right? So if we didn't do anything, that top line, its parameter name would be automatically, as we attached it to an expression, it would just be arg1 or arg0 or whatever it would be. The bottom one allows you to also name that expression, because a parameter can also have a name, right? Constant expression is another expression. It's another example of an expression that represents a constant, some kind of a string or a number, something then inline in code that can be read, and it is basically just a wrapper. It says this expression just points to something that already exists inside of code, outside of the expression world. And a method call expression is a call to a method, right? So this is how you would declare one. Now, one thing about the expression API is that it is there's a lot to it, right? There's lots of different kinds of calls, right? There's calls to static methods, there's calls to instance methods. So there's lots of different ways to construct a parameter or construct a expression for declaring a function. But here's a simple example. So we're just going to use just a little bit of reflection. We're going to declare a parameter that is of type string, and then we are going to get a reference to the toUpper method inside of the string class. So it's broken down into one of two things. If you've never used get method, we get the name of the method, and then we get the things. This is an array. This type.emptyTypes is an empty array of types. It just basically says what is the signature of this function. That's the one we want to find. And then we can use the expression.call to actually declare our method calling in line. So we're going to build this thing. We're going to build this guy right here. We're going to do our string toUpper, and we're going to do it using the expression API. Let me show you. So string toUpper starts with our expression parameter. So we've got type of string, but we also want to give it a name. We've called him str, so we're going to call him str, and we're going to declare that expression.parameter. We're going to go ahead and call him str. So we're going to use the second argument of that expression parameter function. And then, of course, we want the reference to toUpper, so we're going to do exactly what we did before, get a reference to toUpper, the toUpper method call. And then we're going to construct the body of our expressions. We got the parameter, we've got the thing that's going to be inside the body. Now we're going to actually call our parameter. We're actually going to call our toUpper method or construct the thing that calls that. So we're going to call expression.call. We're going to pass in firstly the parameter because we're calling it the toUpper method on our parameter, right? We're calling str.toUpper, so that's the target. So that's what we're going to do, and we're going to give a reference to our toUpper method. And then we're going to do this. This is expression.lambda. Expression.lambda, what it will do is it will actually convert this into a function that can be called in line. So here's how you would actually invoke it. So we've got our expression.lambda here. We give it a body, and we give it a parameter, either 0 or more, right? So we've now actually created what's called a lambda expression. And what we can do in line with this is we can either read it, or we can use it. We can call this compile method, and it will literally, when you call lambda.compile, it will build that in memory, and it will make it into an actual function. And then we can call dynamic invoke on it, pass in the arguments, right, because we know that it is a function that takes in a string. So we're going to call it with Spencer. And then what we're going to end up with is we're going to get the capitalized name. We're going to get my name capitalized, right? So one thing about this is that it's not strongly typed. You actually pass it in an array of parameters. But if you happen to know at runtime the type of the function, if you know the signature of the function, you can call expression.lambda, and what it'll give you is a lambda expression that actually is fully typed. So that way when you call .compile and then you call invoke, you get it will be strongly typed. So that way you can't pass in, a number or 0 arguments or 3 arguments like you could if you called dynamic invoke. All right, so pretty useful so far. So that's our thing. What could we do with expressions? We can read them, we can use them, we can create them. So let's talk about some of the real-world use cases for expressions, the ones that we use every day, maybe take it for granted, we don't even know what's going on under the hood. So let's peel back those layers. Let's look under the rock. So we got Entity Framework, which I saw a lot of hands for Entity Framework, which is awesome. How many people use AutoMapper? AutoMapper is one of my favorite time-saving libraries. If you were in my workshop, I'd talk about AutoMapper same way I talk about any framework. I love them. I love them to death. So we're going to go through how both of those use expressions to do their job. So Entity Framework is a piece of functionality that is a wrapper over a database, right? And it allows us, one of the things that it allows us to do, which has a lot of power, is write LINQ expressions, which Entity Framework will automatically translate into SQL, which is really useful, right? It saves us a lot of time. We don't have to write a lot of nasty SQL, which is great. So something like this, where if we had a products table, and the products table had a name and a price, we could say products, if we wanted to go through and find all the products, and then we wanted to find the most expensive eggs in a list. So we could call db.products, call .where, which gives us, what's called a predicate. We can pass in that product, and then we just give it we return bool and say, well, p.name equals eggs. We've done this before, right? If not Entity Framework, link to objects, certainly. And then we call order by descending. So the cool thing about Entity Framework is it will take that knowledge and it will translate it into SQL, which is really cool, right? So we get select star from products where name equals eggs, order by price descending, roughly. How many people have really looked at the SQL that Entity Framework, how many people like looking at the SQL that Entity Framework emits? Nobody. So this is like a very cleaned up example. It gives you a right idea. Of course, Entity Framework behaves a little differently. It emits lots of crazy SQL. But there's some magic in the middle. There's something in the middle that's happening that's causing Entity Framework to take that expression and then turn it into a SQL query. Is it magic? Probably. Must be, right? I mean, if all you're doing is writing queries, you don't know what's going on under the hood, which is fine. It's just doing its magic, right? So interesting property about db.products, it is what's called an iQueryable. It is of type iQueryable, which is like IEnumerable with a few extra things, right? iQueryable is the magic that enables things like expressions and LINQ. It enables us to look at expressions that we pass in Entity Framework and do stuff with them. So here's an example of a enumerable. So Queryable and enumerable, very similar, and they both have lambda expressions, they both use LINQ, right? They both have where and select. You may have not even ever noticed this, right? So if you've got enumerable and you call .where, if you've got an enumerable you call .where, you get that extension method, right? Where is an extension method that takes in a func that says pass in your thing of type t and then return a bool. And then what it'll do is typically it'll use that to filter down some results. But Queryable is a little different. Queryable doesn't take in functions, it takes in expressions that describe functions. So what does that mean? That means that this one can be interpreted at runtime by Entity Framework, which is really awesome. So this is our little query that we need, or our little LINQ query that we need to decompose down into its component parts and turn it into SQL. And how does it do that? How does it make that magic happen? It does that by implementing something called an expression visitor, which is used to read and operate and sometimes modify expressions. So let me show you. Let's break this down one piece at a time. So we've got our DB products. We know that represents our products table. So now we're trying to query that table. So what we're going to do is what's going to happen is that the expression visitor, that expression is going to go into the expression visitor. It's going to be read, it's going to be read, it's going to be read, and then it's going to be translated, right? So one of the things that it can do that it's really useful for is visiting expressions, just reading them so that you can translate them into another language. In this case, we're trying to translate C# into SQL, and it does a good job of that. So when we pass in p.name equals eggs, it becomes where name equals eggs. It becomes something that SQL can interpret. It becomes the SQL language. This is what's called a binary expression, and a binary expression is really important because it represents something that has a left side, a right side, and an operator in the middle. Greater than or equal to, equals, not equals, that kind of thing. So a binary expression has a left side, a right side, and an operator, a node type, right? The node type is usually like equal, not equal, that kind of thing. So the expression visitor reads each piece of that expression and operates on that expression. So when we look at this p.name equals eggs, we're looking down and we're breaking down that where clause. We know that the left side, p.name, probably translates to a name column in SQL. We know that the double equals is also something that can be read from the binary expression, and we know that a double equals is a single equals in SQL, or at least the expression visitor does. And then, of course, the egg string, the egg constant, it gets passed in as a constant to this function, right, to our call to where. And of course, we don't have double quoted strings inside of SQL, so it just translates it to a single quote string. So it will make it into SQL, so that way it can be executed against the SQL database. Let it do the thing that it wants to do. So now we know the magic in the middle is actually an expression visitor. And we could spend all day, we could do an entire workshop on how to implement an expression visitor. We're not going to cover that today. We're just going to cover what it is, because it's important to understand kind of what's going on under the hood. The expressions are being read, so that way that we can do something with them, right? So, of course, one thing about C# and SQL is that C# is decidedly not SQL. It took me a while to find an example, a good example of a SQL query. This is an example of a SQL query that Entity Framework would admit. Entity Framework has to work really hard in order to translate what is essentially C# into SQL, right? Because they're not the same language. They have a lot of similar properties, but not everything. We can't write C# and expect it to operate like SQL. I had a developer one time ask me, he said, well, I wrote this SQL query, and I put two things in the where clause, and I just figured that the and part, if I had two things in the where clause, if the first and wasn't satisfied, then it would just short circuit and not look at the other one, and it will gain performance that way. That is not how that works. Those kinds of idiosyncrasies make things like that make translating C# to SQL difficult, right? Another great example is what's that? Case sensitivity inside of the collation inside of a SQL Server database. If you have an in-memory SQL Server database, or a database that Entity Framework is using for testing or something, and you do where equals, it's going to be case sensitive. But a lot of times, how many people have a SQL Server instance that is not case sensitive by default? It's awesome, right? But those kind of idiosyncrasies exist, and we have to correct for them. We could all read this if we really wanted to. Nobody wants to read this. But you see that this is the kind of, being that this is like output of a really, big, arguably nasty LINQ query, Entity Framework has to work hard, right? That's part of the expression visitor's job. Another thing that expression visitor can do is modify expressions, kind of, because the expression API returns immutable objects, which is great. because they will always have a state, and when you get them back, as long as that line of code executes and you don't get an exception, you know it's a valid expression, which is really cool. So expression visitor can be used to modify, and let's look at an example of this. So let's say that every time we had an expression that we wanted to look at, we could construct a visitor to always make sure that when we're looking at that, if there's a string that's passed in, that we translate that expression to a to-upper expression. So now we're using this, now we're replacing it. We're still keeping that variable, right? But we're also now calling to-upper on it. So instead of a constant expression, for example, we'll end up with a method call expression. And we can do that by implementing an expression visitor and calling and implementing the visit method. So basically, if the node type equals to expression type.parameter, we want to make sure to return it. We don't want to mess with parameters, right? But if it's anything else, it's fair game to be called, to be modified. So if the node type, because there's a property on node on all called type on all expressions, if the node type equals type of string, then we're going to use, instead of returning the expression, we're actually going to modify it. We're actually going to replace it with the method call expression and call to-upper on it. Such that when we do this, we declare a function in line called Spency string, apparently, and we take in an S, which is a string, and then return S belongs to Spencer. If we run that through the to-upper visitor, what will happen is that expression that we get after we call visit and convert will be a new expression, and when we compile it and invoke it, we'll get the cheese belongs to Spencer and everything will be capitalized. So I have a demo for you, and I am going to, if you've got a computer and you want to follow along, I'm going to, oh boy, does this Twitter link still work? Oh, right, I'm going to go here. Oh boy, this is going to be, there we go, I can see that. All right, so I'm going to tweet out the link to this. So this is a thing called, what is this? Oh, .NET Fiddle, which is really useful for sharing really small snippets of code. So NDC Minnesota, tweet that out. Now you got a link to this .NET Fiddle in case you want to follow along. And in case you want to reference it later, you've always got a link to the slides too. And well, cat's out of the bag because it's already run and it's already been run before. But you get to see, you can take this and then you can experiment with it, right? So it's got our to-upper visitor declared with our visit type, and you can take this and mess with it. It's a little bit of example code. It makes messing with expressions a little easier sometimes when you have a little expression. So if we wanted to call to-lower instead, we won't rename it. To-upper visitor, it's now the to-lower visitor. We've added a bug, right? I'm going to run this, and you're going to see when we go through, when the expression is modified and looked at, it's going to return, that's maybe a little bit too small. It's going to return the cheese belongs to Spencer in lowercase, right? So just an example, if you have an expression, you can take them and modify them using a visitor. Let's see, how do I need to switch back to this. All right. Let's talk about AutoMapper. AutoMapper is one of my favorite libraries. It saves me from writing glue code, and glue code means that I'm doing fun stuff as opposed to boring stuff. Instead of declaring another instance of a class that has all the properties of the previous one, I can use AutoMapper to copy those properties over to that class, and it's awesome, right? And you can manage your maps and use them to do some specific things, including things like interact with LINQ. Let me show you. So this is an example of a map, right? So create map, if you call create map on an object, on a class, on two classes, what you'll get is it will create that map in memory, and it will manage it it will hold it in memory, and when you call .map from this mapper, it will then go look in that map and use it. So it will automatically map like properties. So if it's a string first name on one class and a string first name on another, when you call map, it will automatically copy those things over. If you need to do some custom stuff, you can call forMember and say for the target property first name, I want you to map from my first name. So you can give AutoMapper a little bit more information to do its job really well. So these things that we're calling, those lambdas, those are actually expressions, right? Because those things are not actually being are not functions that are being called. They're just being interpreted. And they're being interpreted and what we get is a nice experience when we're developing. It's very convenient. One of the hardest things that I think that I explain to junior developers is when that where clause, that where in like DB products, that where clause is actually never invoked. It's just read and translated, right? Same thing here, same thing for AutoMapper. Let's talk about project to. If you were in my workshop, I talked about project to a lot because it's one of my godly things. I love this thing because it can use expressions in really powerful ways. Let me show you. So let's say that you have some kind of item detail class, and for our sake, we'll just say it has an ID and a name and 100 other properties. So 102 properties to map, right? So, and then we've got it, we need to project it to a list of some kind, right? So we just need to take that and we just need to copy over the ID and the name from the database and then put it in a list if we're, trying to select it in a drop-down selection or, on a web page or something, right? So we can combine AutoMapper and Entity Framework and call mapper.map, item detail model, give it the type item detail model. It will say, oh, you're giving me a set of item details. I know that I'm going to translate them into an item detail model and return the right data. But here be dragons. And the dragons come in because this will call select star on that table. And how do the DBAs that you work with love select star? They hate it, right? You don't want to make the DBAs mad because then they yell at you and then they make you refactor your code, right? So project to is a really powerful thing that can help come to the rescue and kind of take some of that pain away. So instead of calling mapper.map item detail model, array of item detail model to return this, what we could do instead is call project to. So db.itemdetails.project to. There's actually an argument that gets passed in. It's the from your mapper instance object, you actually pass in the mapper's configuration. But you get the idea. If you're using the static AutoMapper, how many people are using the static API for AutoMapper? Okay, wow, very good. Very few of you. If you've got existing code, you don't always need to refactor it. But if you do use the instance base, there's an additional argument that's important. But what this will do, what's really cool, is that AutoMapper will use expressions under the hood and tell Entity Framework they're really only selecting these two properties. So when you call project to on this item details model and tell it to project it to the item detail model, right, you'll get a select ID common name. So AutoMapper and Entity Framework can work together a little bit to actually take those expressions and use them to write more performant code. Or if performance isn't the issue, then use it to write code that your DBA won't hate. So let me talk about a real-world example at my company. So I work for a startup called Rivet, and Rivet makes integration data. They make integration software. So they're making data and workflows. They're trying to connect two systems to either connect list data for accounting systems like customers and vendors, or emulate workflows for integration of certain products. Really powerful, really cool stuff. And it's a startup. I've been there for about 4 years. And we encountered a problem in an early version of the platform. So essentially what we did was we'd always pull in a local cache of all of the data. So that way we can manipulate it and reference it very easily. There's a lot of good reasons to do that. So what we'd do is we would create those in SQL. We'd create SQL tables for all those, and then we'd copy in the data. Pretty straightforward. The thing we needed to do was be able to map one entity to another. And they used stored procs because by the time I got there, they started using stored procs for performance. What they were doing previously was using Entity Framework, calling for each of the objects, on the objects, and then copying over the data. It was very slow. It was not performant enough. And stored procedures, because they're compiled, and because they're SQL and use insert set-based logic, they were a lot faster. So let's take this for example. We're going to take a Salesforce customer and make it into a QuickBooks customer. So oftentimes when you're working with data from different systems, as you know, you've done integration before at least a couple of times, I'm sure. It's a lot of our jobs these days. And of course, we know that sometimes the data doesn't always quite match up. If it's not a property name, maybe it's just kind of a purpose, right? It's maybe the property doesn't quite represent the property on the other thing, right? But let's say, for example, that we have like a Salesforce customer and a QuickBooks customer. And we want the Salesforce customer, for one reason or another, is called customer name, and we wanted to map it to the QuickBooks name property on that customer. And then we have a create date, which kind of sort of goes with open date. Well, we go with it. That's just what our product definition says, so we go with it. So our job is to copy over all of these properties from one entity to another. So this is what our stored procs looks like. We'd say insert QuickBooks customer name, open date, select customer name, create date from Salesforce customers. And of course, there was a little more complication to that. We wanted to make sure we weren't including duplicate data, for example. But you get the general idea, that we would write stored procs to move this data around. Now, do that for hundreds of objects and thousands of properties. Oh, and by the way, don't ever make a mistake. How many people love writing SQL because it just helps you out so much from keeping you from making mistakes? Right. Right. The people that raise their hands, those are, sadists. Those are the kinds of love pain, right? But for me, this was not a scalable solution. For our company, this wasn't scalable. We were making mistakes all the time because SQL doesn't provide a lot of those protections that we're just used to in C#. So we had some problems there. So I went to my boss one day, and I barely knew, I knew of expressions. I knew about them conceptually. I don't know if I watched a talk, read a blog post, whatever. I knew what they could do. I knew that they could be read and interpreted. So I went to my boss, and I said, Michael, I think there's a different way. I think there's a better way we can do this. These stored procedures, there's a lot of pain associated with them, but I think that we can do this in code by defining maps in code. And he said, you can show me a proof of concept. You have an hour. So I said, all right, I've got an hour. So in 40 minutes, I had some workable example. And it essentially kind of looked like this. And what this did was we were able to define classes, kind of like maps, kind of like AutoMapper does. We were able to define a class that would represent a mapping between those two objects. So we would say source field from the customer, from the Salesforce customer, is equal to the qbc.name.trim. So what we actually did, I actually think I have that inverted a little bit. I think that the trim belongs on the customer name. So we wanted to trim the customer name first because a lot of the older systems that we integrate with, they just love padding spaces on the ends of things. They just love doing it, or at the beginning, right? I don't know why they do, but they do. Sure, I'll deal with that. But in QuickBooks, they don't like doing that. So we wanted to trim that name. And then we wanted to say, well, the source field create date, we really want to take it and put it to the open date, but we don't always have a value, but it's a required value in another system. So we'll do datetime.now in case that value is null. So the thing that I had to do was write an expression visitor because I had to preserve the performance of the stored procedure while making it really convenient for developers to write. So I had to write an expression visitor, and then I had to handle pretty much any type of expression that we wanted to translate. How many people have ever tried to call a method or something inside of an Entity Framework query, and Entity Framework's like, I can't translate that, I don't know what to do, it throws an exception, right? A lot of us have encountered that error. We had to do the same thing because sometimes the functionality just didn't copy over, right? So when we called trim on a name property, what we were actually wanting to do was call ltrim, rtrim inside of SQL, right? And then when we used the coalesce operator, we wanted to actually use the isNull we wanted to actually translate to the isNull function. So we had to capture all of this intent inside of that expression visitor. So that way we could write really natural C# that was also really performant in SQL. And it emitted nice, and moment of pride, right? It emitted nice looking SQL. Granted, our use case was a little narrower than pretty much, Entity Framework in general. But what we ended up with was really nice looking, predictable SQL. So our DBAs didn't kill it. Actually, at the time, we were the DBAs, which is, Anyway, so this became a really predictable process to create these maps. So we went from stored procedures, and we immediately, as soon as this system had any maturity, we immediately switched to doing this. We switched all of our definitions from stored procedures to this. It was predictable, and it saved thousands of hours of development time. Thousands of hours. This is the back of the napkin, right? From debugging all the way to development, because stored procedures are really hard and nasty. And the really other cool thing that we were able to do with our visitors is we were able to button additional functionality on top of them such that we could write and run additional queries using that metadata in order to make sure that we could prevent duplicate data from moving from one database to the other. Stuff like that. It became a huge boon to productivity, and people really liked them. And it went all the way down to doing joins. It was really awesome, and it saved a lot of time. And it made a lot of money too, I think. So let's talk about some other real world examples. So that's my personal story, a really good one. But maybe you have, we're wanting to do something like order by like a string, right? Like order by some kind of property. If you've ever constructed an API of some kind, ever constructed an API? Lots of you have, right? We might have done something like this at some point, or you might have at least seen or consumed something like this, where you had an API, a customer's API, and this is a URL, right? where you had it on the query string where you could order by equals to name. Okay? This is what it would look like inside if we were doing a database query, right? But the problem is that it does not expect a string, it expects a lambda, right? It expects an expression. So this thing doesn't exist. So the solution for us is to use the expression API to actually cook a reference. We're going to actually create that lambda in memory using expressions. So our goal is to end up here. And we can do that by using this iQueryable that I think I got from Stack Overflow and tweaked a little bit. So what we're going to do is use this. We're going to create an extension method where it's order by property or field. And we're going to take an existing iQueryable or IEnumerable, whatever the case may be, take a field or property name, give it a property or field name that we want to order by, and then do we want it to be ascending or descending. So there's a very simple function signature. So our first thing is to, we're going to make this an iQueryable so that way it can also be used by Entity Framework. So we can take advantage of the performance, the sending our order bys down to the SQL Server. So we want to cook it our expression, and then we want to apply it to our queryable chain. And we can do that by defining an expression that represents the type. So first thing we need to do is capture the type. So we know type of T, so we want to get the type of that element, right? If it's an iQueryable, you could also just call it, dot element type, same thing. So then we want to create the parameter, right? We're trying to recreate that C it goes into C.name. We're trying to recreate that expression. So first thing we need to do is, for our expression, is build the left side. So we're building the parameter. Pass in a type. Perfect. We'll give it the element type of our iQueryable. Makes sense so far. So then what we want to do is capture the property. So we want to capture that property that exists on that class. So what we'll do is call expression.property or field, which is useful because it's nice. You don't have to know one or the other. You can give it the instance of the thing that you want to capture. In this case, is our expression parameter. And then we want to give it the property or field name. Now at this point, if the property or field name didn't exist on the class, it would throw an exception. It wouldn't go anywhere from here, right? But assuming that it did go on, we want to get our name, right? So then we do this selector. So we say expression.lambda, and now we're ready to construct it. We're ready to construct our expression. So we pass in our property expression, which is going to be the body of our expression, and then we're going to pass in the parameter. Because we only have one parameter, so we only need one parameter passed into the lambda. So we've achieved our goal by using this order by using expressions, just cooking a custom expression at runtime. So here is, if we wanted to actually use that order by and actually apply it to something. Hold on. This is where we would actually construct the call to order by, right? So because we've got the expression, now we want to apply it to the chain, the iQueryable chain, and we do it by this. So this looks a little intimidating, and this is the part where discovery of the expression API, if you've got Visual Studio, you've got LINQ which is a great tool, that would help a lot. I don't memorize any of the expression API except the simple stuff. The rest of it I use autocomplete. I use IntelliSense to help me with. First thing we need, though, we need the name of the order by method. We know that because we use it inside of the enumerable.orderby or order by descending. Of course, we could use name of, but for the sake of this example, this looks good too. So if the thing is ascending, if we want to just order by ascending, then we just want the order by method. We want the order by method name. Otherwise, we want order by descending. And then we construct our expression.call. So let's break this down a little bit. So first thing we need to do, so since the expression.call, since this queryable order by or order by descending are static methods, we don't need an instance of something. We actually just need its type. So we say type of queryable, because that's where our order by and order by descending live. We have our name of the method. And then we have our generic type signature, because that is a type. It is order by of blah, blah. It's the type of the iQueryable, and then the type of the thing being selected. And then we have our parameters to that particular thing. Since it's a static method, it has two parameters. It has the previous iQueryable, and it has the selector, the lambda, the expression that we created. So now we've gotten all this. We've got expression.call, and we've got it constructed. Let's take a look at an example. So I'm going to use Twitter, tweet this bad boy out. So I'm going to hit escape, get that out of there. Got an order by property example. We will do that. And we will tweet it out because it is super cool. And you can follow along or just check my Twitter later to try it yourself. All right, now we're going to go back to our fiddle. And what I've got here is just a set of employees. I've got a set of employees. I've got Gary. I'm going to make this just a little bit bigger. I've got Gary. I've got his hire date. I've got Spencer. I've got Michael. I've got Amy. And for every employee dot as queryable, so since it's just an in-memory set, we call as queryable to get it properly typed so we can use our order by. We're going to say order by property or field, and we want to pass in the name property because we want to order by name. And what we'll end up with is, I can pull this up a little bit, or I can just zoom out. That's fine too. We'll end up with Amy, Gary, Michael, Spencer. And here's the fully completed thing. I ripped shamelessly from this, for my paging example, which I think was also, that order by was taken from a Stack Overflow question. Thank you, Stack Overflow. And here's the implementation, the same thing we just described. So now you have the code, you can look at it and you can kind of mess with it and see what it does and play with it a little more. If we put in hire date instead, by golly, I should expect that we will order this by hire date. So we should get Spencer on top and then Gary, Michael, Amy. Spencer, Gary, Michael, Amy. Right, because we're ordering by hire date. We don't put in the proper type, or sorry, the proper name of a property, we get an expression. So it would throw on the call to property or field, it would say QWER is not a member of type employee. So, really handy. I have a little code to play with too. Awesome. Let's keep going. The cool thing about expressions is once you know about them and once you know their power, you can start to really dream up and do a lot of cool things. What about our own rules engine or search filter system or whatever? Let's do a rules engine. Let's do a very simple rules engine. So we're going to define something called a rule, and we're just going to have it's going to have a name of a property on an object and then a value. So we're going to try to create a representation of like a predicate, right? Where name equals Spencer, something like that. And then what we have is an operation, and I've just basically just kind of boiled it down to greater than, less than, or equal to. Nothing really complicated. And then what we have is we're making a search system. We're making a filter system. And we want to translate the intent of that filter. For some reason or another, it's really complicated, so expressions come to the rescue, right? So we're going to define our rules in memory. So we can say name equal to Gary and hire date greater than 1/1/2016. So we can cook an expression given a rule set. So this is where we could use our binary expression, again, to do some magic. So we're going to start with a null binary expression, and we're going to say for each rule in the thing, we're going to create a new expression. So we're going to capture the property, so the property name from that rule, and then we're going to capture the value in expression.constant. And then what we're going to call this method called makeBinary. And rule.operation, that would not necessarily compile. That actually would not compile. We'd have to use the node type, which is provided in enum. But for sake of argument, we're just shortening the code up just a little bit. Let's pretend it's a node type. We say rule.operation. We'll say it's equal. And we were just basically wanting to create an expression that represents this property equals this value. And then, if our binary expression is null, let's create a new binary expression, or we'll make it a binary expression that includes the existing expression. So we'll just wrap them up. So we'll end up with 3 binary expressions for 3 rules, right? So this, because of expression magic and because we're using Entity Framework or whatever we're doing, this becomes this at the bottom. So what we've done is used a representation of a rule in memory to actually translate it and create a Lambda. Really awesome. And of course, I have an example for that too. Because it's so awesome, everything is awesome. Yeah. Everything is great when you're clicking around. I think I spelled that right. All right, NDC Minnesota, very good. Order by, here we go, here's our rules engine. So this is the thing right here. So we've done basically exactly what we talked about, which is this is the implementation of the rules engine, almost the exact same way that I did it, except this one actually compiles, right? So scrolling down, we've got our same list of employees, and we've got here a set of rules that we've defined in memory. So we've got name equal to Gary, hire date greater than 2016. And so what we've done is we've just taken the rule, we've just copy-pasted the example in a running .NET Fiddle. We've got our employee, we've got our rule, and then this is the thing that actually takes the rules in and then actually does something with them. So it's doing exactly what I said. It's cooking a binary expression, and then it's cooking more and more binary expressions until it's captured all of the intent of all of those rules in expressions. So when we run it, which it was already run, we see that our rule is Gary 1/1/2017. If we change this name, expression equal to something, we'll end up with nothing. So it doesn't write anything because nobody's name is KSDK. Got here, let's see, we've got 2 Garys. So what happens if we take out this this hire date rule and we just have Gary? As we predicted, we run it and we get both of our Garys. Hooray! And that's expressions. That's expressions in a rules engine. Really awesome stuff. I have built similar systems to this, but there's usually there's existing things out there that you could use. But sometimes when you want to know what's going on under the hood or you need something custom, that's where something like this starts to shine. So I'm an example like this. So let's talk about expression versus reflection. So expressions, if you so how many people associate reflection with slowness? But that it's slow. It typically is compared to doing something that's not reflection, right? Reflection is incredibly powerful. I use reflection. The entire platform of Rivet is built around reflection because it's so powerful. And usually you just have to be fast enough, right? But if you need to extract as much performance as you can out of an application, you can often use expressions. You can take that reflection, and if you can take that reflection code, if you can convert it and make it into an expression and then compile it and then save that compiled expression in memory, what you've got is something that is just as fast as code that you wrote that's compiled. Reflection does have more power. It just does. But expressions capture a lot of what reflection can do. So they're related. They work hand in hand. But there are reasons to use one over another. Also, got to keep in mind that C# does compiler magic. Its compiler does magic to make your life easier. Let's take this for example. So we've got 2 different things. We have a function and an expression that represents that function. And we call combined strings. We've got a combined strings, and basically we just take in 2 strings and return those strings concatenated, right? Same code, it looks the same, it behaves the same, right? But so let's say, okay, well, all right, we should be able to use the make binary expression. We should be able to say expression type.add right here, right? And then give it the string parameter 1 and string parameter 2. Nope, you can't do that because exception, the binary operator add is not defined for the type system string and system string. Well, what the heck's going on? I just did it. I just did that one. But under the hood, C# doing magic. This one, if you looked at this expression inside of LINQPad, if you broke it down, an expression by LINQPad, a great way to, if you call the dump method on that expression, you can see all the little component pieces. LINQPad is awesome. And if you look at this thing under the hood in a debugger or whatever, or just break it down and write it to the console, this doesn't use add, it uses string.concat. It actually converts this into a method call. Because under the hood, what's actually happening is string 1 plus string 2 is actually just using string.concat. Right? And that's just the C# compiler doing magic. Another thing is that conversions have to be managed explicitly. If you pass an employee object into a function that expects an object, just an object, right? It will just work, right? C#, you don't have to convert that. You don't have to cast it to an object. It is an object. C# knows this. The compiler knows this. But under the hood, it actually is casting it to an object. Well, if you do this in expressions where you pass in an employee where you're supposed to be passing in an object, what will happen is the expression won't work. It will throw an exception and say, no, it's expecting of type object. So then you actually have to explicitly use expression.cast or something to actually cast it to type object. So conversions have to be handled explicitly. Just a couple of things. As you're starting to use expressions, as you're starting to experiment with them, these are the kinds of things that you'll encounter. So my favorite way to start is to experiment. I've got those .NET Fiddles out there. They're on the Twitter, as my boss says. They're on the Twitter. They're on my website, schneids.net, so you can go there and get those code samples, copy paste them around, mess with them, right? That's what experimenting is probably your best way to learn more about expressions. Just using the API, learning about its capabilities, what it's able to do, is going to be your best tool. LINQPad, again, I love that tool, linkpad.net. One of the versions is free. It is worth every penny of the $50 that you pay to get autocomplete and some other features if you want a debugger and stuff like that. Really useful tool. And then Google. The expression API is covered well in Google Stack Overflow. It just is because lots of people use them. We all use them. Even if we never knew it before, now we know it. And do what we do best, which is just use IntelliSense. Use IntelliSense to your advantage. It's there for a reason. And did I mention that you should experiment if you want to mess with expressions? It's the best way to get started with them, my opinion. Anyways, thank you very much. As usual, I always say this spiel at the end of my talks. Just because I leave here today, I'll fly back to St. Louis tomorrow, doesn't mean this conversation has to end. Find me on Twitter. My email address and my GitHub, all that stuff is on my website, schneids.net. I'm always happy to answer questions. And if you have questions or if you have a specific scenario or whatever, reach out to me. I try to be responsive at least, So nothing more to say. I hope you've enjoyed this conference. NDC, of course, throws an amazing event. I hope you found it valuable, and thanks for coming. Thank you very much.